Today, I'm about to discuss the problems based on integration by substitution method. So, in this video, I'm about to discuss the 10 questions on integration by substitution method. So, in that, the today's first question is like this, that is integration of cos cube x into e to the power log of sin x into dx. Okay, this is our given question. And to find the solution of this problem, so you can rewrite the given problem. So how can we rewrite? We all know very well e to the power log is both will get cancelled because e and log both are reciprocal to each other. So that the given question can be rewritten as integration of cos cube x into sin x into dx. And see, this is in the form of one of the standard formula. The formula says f of x to the power n integration of f of x to the power n into f dash of x into dx is equal to f of x to the power n plus 1 divided by n plus 1, which means if the function is of the form integration of f of x to the power n into f dash of x into dx, then its answer will be f of x to the power n plus 1 whole divided by n plus 1 plus c. This is another shortcut method. Without using substitution method, we can do it. But the thing is, the given question is not exactly in the form of as we have noted the formula. So we can reduce it in such a way. How? We can rewrite the given question as cos x whole power 3. Differentiation of cos x is minus sin x. Here the minus sin x was not given, so I have took the minus sign, which means let us write one more minus sign in the beginning. Now you can observe this is exactly in the form of f of x whole power n into f dash of x into dx format. Then what will be the answer to the given question? Minus f of x to the power n plus 1 divided by n plus 1 plus c. That is cos x to the power 3 plus 1 whole divided by 3 plus 1 plus c. Even we can write it in the form of minus cos power 4x whole divided by 4 plus c. This is our final answer. Hope you have understood. Let us move on to the next question. The second question is integration of, moving to the next slide, integration of 10 to the power x by 2 whole divided by square root of 10 to the power minus x minus 10 to the power x into dx is given. How to find the solution to the given problem? Let us think. See, directly again the given problem is not related to any of the standard formula. So let us rewrite the given question. Can we rewrite which is of the following form? That is, within the square root we have 10 to the power minus x. That can be rewritten as 1 divided by 10 to the power of x. Minus 10 to the power x is as it is, into dx is also as it is. Now in the denominator, you can take LCM. What is LCM? 10 to the power x is an LCM. Then the numerator will become 1 minus 10 to the power x. The whole square is nothing but, okay, I will write like that only. 1 minus 10 to the power of x the whole square whole divided by 10 to the power x. Since the square root is applicable for both numerator and denominator, so we can rewrite the given question as integration of 10 to the power x by 2 whole divided by root of 1 minus 10 to the power x the whole square the whole divided by 10 to the power x to the power 1 by 2 is nothing but x by 2 only will get. And we all know very well that the denominator of denominator will go to numerator. Accordingly, this denominator of denominator will go to numerator. So that what we'll get? We get the question as integration of 10 to the power x by 2 into 10 to the power x by 2 whole divided by square root of 1 minus 10 to the power x the whole square, okay, into dx. Now again you can observe the numerator. Numerator is in the form of a power m into a to the power n format. When base is same, power can be added or subtracted, so that we get 10 to the power x by 2 plus x by 2 whole divided by square root of 1 minus 10 to the power x the whole square into dx. So here both numerator and denominator are one another the same, so that we get 10 to the power 2x divided by 2 is nothing but 10 to the power x only, whole divided by root of 1 minus 10 to the power x the whole square into dx. Now in this particular step we can use the method of substitution. So here what is composite function? Square root of 1 minus 10 to the power of x the whole square is to be considered as a composite function. So inner function is to be considered as a substituting variable. Assume 10 to the power x is equal to t. Differentiate LHS with respect to x, RHS with respect to t, so that we get, this is in the form of a power x formula. Differentiation of a power x is a power x into log a into dx is equal to dt. Now when we observe the remaining part of the problem, we have 10 power x into dx. So find out the value of 10 power x into dx. 10 power x into dx is equal to dt divided by log 10 we will get. Substituting 10 power x is equal to t and 10 power x into dx as a dt divided by log 10, the given problem will become integration of 10 power x into dx is nothing but dt whole divided by log 10. In that 1 divided by log 10 is a constant, remaining is only dt whole divided by root of 1 minus 10 power x we have already assumed as a t. So 10 power x the whole square will become t square. And when I find the integral of this function, we get 1 divided by log 10 is a constant, we are writing as it is, and integration of dt whole divided by root of 1 minus t square is sine inverse of t plus c. So this is our answer. But here when the question was given in terms of x, you cannot write the answer in terms of t, so that we will substitute back the value of t. What we took the value of t? We took the value of t as a 10 to the power x, so that the final answer will be 1 divided by log 10 into sine inverse of t. Sine inverse of t. What is the value of t? T is nothing but 10 to the power x plus c. Yeah, this is our answer. So answer is 1 by log 10 into sine inverse of 1 by log 10 into sine inverse of 10 to the power x plus c. Yeah, this is our final answer. Now we are moving to the next question. Question number 3. What is third question? Let us see. Third question is integration of x square divided by x square whole divided by 1 plus x square whole to the power 3 by 2 into dx. Okay, yeah, that's the given question. Now to find the solution of the given problem, look at both numerator and denominator. Here numerator is x square and the denominator is 1 plus x square. So we will try to rewrite the given question which is exactly similar to the numerator, okay, so that we get integration of x square. So we have in the denominator 1 plus x square, so I am trying to reduce it in the same format, which I mean to say add and subtract by 1 whole divided by same denominator, that is 1 plus x square to the power 3 by 2 into dx. Now later on you can make a group in the numerator. First two terms is to be considered as a one group and the last term is to be considered as another group. So integration of 1 plus x square whole divided by denominator of 1 plus x square to the power 3 by 2 can be rewritten as 1 plus x square into 1 plus x square to the power 1 by 2 we can say, because whole power a power m into a to the power of n can be written as a to the power m plus n. So 1 plus 1 by 2 will become 3 by 2 only into dx. This is first term minus integration of dx whole divided by 1 plus x square to the power 3 by 2 will get. Okay, yeah. Now further what we can do, in the first term both numerator and denominator 1 plus x square can be cancelled, and we are left with integration of dx whole divided by root of 1 plus x square into dx. Yeah, we have a standard formula, we can find the integral of this function as easy as possible. But the next term is integration of dx whole divided by 1 plus x square to the power 3 by 2 is given. How to find the integral of second term, that we need to think. So here to find the integral of the second term, we can use the method of substitution, that is by taking the value of x as a tan theta. Why we should take tan theta only? Because 1 plus tan square theta is secant square theta. So with that hint we can solve this problem. So before that I will write one standard formula to find the integral of the first term, that is integration of dx whole divided by root of 1 plus x square is nothing but log of modulus of x plus root of 1 plus x square plus c. Okay, this is a formula to find the integral of the first term. Now to find the integral of the second term, what you can do, we can take the value of x is equal to tan theta. When x is equal to tan theta, dx, when we differentiate both the side, LHS with respect to x and RHS with respect to theta, we get differentiation of 1 is dx and differentiation of tan theta is secant square theta into d theta we will get. So this implies that integration of the first term is log of modulus of x plus root of 1 plus x square we will get, followed by this minus sign as it is, integration of, I am substituting the value, dx value is nothing but secant square theta into d theta, whole divided by 1 plus tan square theta whole to the power 3 by 2 is given, whole to the power 3 by 2. Let us simplify. So first term we have already simplified, so we are carry forwarding the same, log of 1 x plus root of 1 plus x square minus, so this one if I simplify, we get integration of secant square theta, numerator is as it is, whole divided by denominator is like 1 plus tan square theta is secant square theta, so that we get secant square theta to the power 1 by 2 whole power 3 we can write. Okay, because 3 by 2 whole power 3 by 2 can be written as 1 by 2 to the power of 3. So here square and square root will get cancelled. Remaining is log of modulus of x plus root of 1 plus x square will remain same in the first term, minus in the second term the remaining terms are secant square theta divided by secant cube theta into d theta. So here secant square will get cancelled, another secant theta will left in the denominator, and we can find the integral of that function as easy as possible, that is log of modulus of x plus root of 1 plus x square is as it is, minus integration of 1 divided by secant theta is nothing but cos theta into d theta. Now what is integration of cos theta? That is sin theta, so that we get log of modulus of x plus root of 1 plus x square minus integration of cos x is sin theta plus c. Now substitute back the value of theta. What is the value of theta? Value of theta is from the given function, value of theta is equal to tan inverse of x we will get, correct? Value of theta is equal to tan inverse of x. So this is equal to log of modulus of x plus root of 1 plus x square minus sin theta. Sin theta is, what is the value of sin theta? If tan theta is equal to x, clear? If tan theta is equal to x, from this, by constructing right angle triangle, tan theta is defined as opposite by adjacent, and hypotenuse will be root of 1 plus x square we will get. Then sin theta will become opposite by hypotenuse, that is x divided by root of 1 plus x square plus c. Yes, this is our final answer. Hope you have understood. Dear student, if you have any doubt, you can put it in a comment so that I can help you to resolve your doubt. Okay, hope you have understood the solution. Let us move on to the next question, that is question number 4. So here fourth question is integration of sin x minus cos x, integration of sin x minus cos x whole divided by root of 1 minus sin 2x, root of 1 minus sin 2x into e to the power sin x, into cos x into dx, Yeah, this is a given question. Now to find the solution of the given problem, let us try to rewrite the given problem. Okay, so if I try to rewrite the given problem, how we can write? We can rewrite which is of the following form, that is, in the numerator we have sin x minus cos x, in the denominator we have square root of 1 minus sin 2x we have. Okay, this 1 can be rewritten as sin square x plus cos square x, and multiple angle formula sin 2x can be rewritten as 2 sin x into cos x. So entire denominator will become sin square x plus cos square x minus 2 sin x into cos x, which means that is exactly in the form of a minus b whole square format. So sin x minus cos x in the numerator is as it is. Denominator we will get it in the form of root of sin x minus cos x, the whole square will get. In this, square and square root can be cancelled. Along with this we have e power sin x into cos x. This one will remain same. Okay. Now the remaining is integration of sin x minus cos x whole divided by, after cancelling square and square root, we are left with the denominator sin x minus cos x, that is exactly same as numerator of sin x minus cos x. Those two terms can be cancelled. What is left? Remaining is e power sin x into cos x into dx is left. Okay, now this is in the form of composite function e to the power sin x into cos x. When we have a integral of composite function, inner function is to be considered as a substituting variable. So our inner function is sin x. So here we assume sin x as a substituting variable. Let sin x is equal to t. Differentiate LHS with respect to x, RHS with respect to t, so that we get differentiation of sin x is cos x into dx is equal to dt. Yes, we are getting the remaining part of the problem. So the given question is rewritten in terms of t as e to the power t, because sin x we took it as a t, cos x into dx is nothing but dt. What is integration of e power t? E power t plus c. Substitute back the value of t. Here the value of t is nothing but sin x. Finish. This is our answer. E power sin x plus c is our final answer. Hope you have understood. Let us move to next question. Question number 5. Question number 5 is integration of x to the power 49 into tan inverse of x to the power 50 whole divided by 1 plus x to the power 100 into dx is equal to k into tan inverse of x power 50 the whole square, like this we have, plus c. Then the value of k is, then find the value of k. Okay, this is the given question. Now to find the solution of the given problem, what we can do, think once. See here, in the given question, they themselves have given the partial solution, which means when we find the integral of the given question, that is LHS, a given LHS, we will get the answer which is of the form k into tan inverse of x power 50 the whole square we will get. But in place of k, we will get something else. What is that something else? Only that they are asking. So we should find the value of k. Now let us think about to find integral of the given question. What is the given question? X power 49 into tan inverse of x power 50 whole divided by 1 plus x to the power 100 is given. That 100 can be rewritten as x power 50 the whole square into dx. Now this problem can be solved by using trigonometric by substitution method. So let us assume tan inverse of x power 50 as a substituting variable t. Now differentiate LHS with respect to x, RHS with respect to t, and the derivative of LHS, especially this is in the form of composite function, derivative of composite functions. So derivative of composite functions can be done as easy as possible by differentiating inner function first and the outer function second time. Okay, so differentiation of x power 50 is 50 into x to the power 49, because we are using the formula x power n. Integration of x to the power of n is n into x to the power of n minus 1 into differentiation of tan inverse of x. Differentiation of tan inverse of x is 1 divided by 1 plus x square. In place of x we have x power 50 whole square into dx is equal to dt. So you can observe here we are getting the remaining part of the given problem as well. Here xs is 50 we are getting. If I shift this 50 to the other hand side, we will get dt divided by 50. Now you can observe x power 49 into dx whole divided by 1 plus x power 50. Yeah, you can observe here I am marking the part. Okay, this marked part is to be replaced by dt divided by 50. So the given question will become, integration of x power 49 divided by 1 plus x power 50 the whole square into dx is nothing but dt divided by 50. In the dt divided by 50, 1 by 50 is a constant that you can keep it outside. Remaining is only dt. And we have already assumed tan inverse of x power 50 as a t. So that this tan inverse of x power 50 will become t. Now find the integration of t with respect to dt, so that we get 1 by 50 into integration of t with respect to t is t square divided by 2 plus c. So when I multiply this, t square into 1 is t square, and here the value of t what we have assumed, that is tan inverse of x power 50. Tan inverse of x power 50 whole divided by 2 into 50. What is the 2 into 50? 1 divided by 100 plus c we will get. Or if I segregate this 1 divided by 100 separately, it looks like this: 1 divided by 100 into tan inverse of x power 50 plus c we will get. So now if I compare this answer with the given RHS, in place of k we have value 1 divided by 100. So the required value of k is 1 by 100. Okay, yeah, this is our required solution. Hope you have understood. Moving to the next question. Next question is question number 6, that is integration of sine root x whole divided by root x into dx. Okay, this is one of the easiest question till now what we have solved by comparing the previous 5 questions. And this question you can do it by assuming root x as a substituting variable. Differentiation of root x is 1 by 2 root x into dx is equal to dt. When we do cross multiplication 2 on the other hand side, we get dx whole divided by root x is equal to 2 times of dt we will get. Then the given problem can be rewritten as integration of sine of root x we have assumed as a t. 1 by root x into dx is nothing but 2 times of dt. In that 2 is a constant that we can keep it outside. Remaining is only dt. What is the final answer? 2 into integration of sine t is minus of cos t plus c. Finish. We found the answer. But substitute back the value of t, because when the question was given in terms of x, you should write the answer also in terms of x only. So minus 2 into cos of t. T is nothing but root x plus c. Finish. We found the answer to the given question. That is minus root of minus 2 into cos of root x plus c. Yeah, this is our required answer to the given question. Now we are moving to 7th question. Here you can observe the 7th question is question number 7. Integration of secant to the power 4x into tan power 4x into dx is equal to tan power mx whole divided by m plus tan power nx whole divided by n plus c. Then the value of m plus n is question mark. We should find the value of m plus n. Options are like 8, 12, 10, 16 are given. Now let us think about how to find the solution of the given problem. So here also they have given the question. For the given question, partial answer also given. That means when we find the integral of LHS, our answer will be in the form of tan power m x whole divided by m plus tan power nx whole divided by n plus c. So in place of m and n, we will be having some numerical value. When we add those two values, what will be the answer? That is what they are asking. Now to find the solution of that question, let us consider the given equation. What is the given question? Integration of secant power 4x is given into tan power 4x is given. So can I rewrite the given question as integration of secant square x into tan x whole power 4 into dx. So why I wrote like this? Because we need to identify what is inner function and what function can be considered as a substituting variable. So by looking at the given question, we can consider tan x as a substituting variable. So let tan x is equal to t. What is differentiation of tan x? Differentiate LHS with respect to x, RHS with respect to t. So differentiation of tan x is secant square x into dx is equal to dt. So we are getting the remaining part of the problem. So here you can consider secant square x into dx as a dt. Now you can rewrite the given question in terms of t. So what we'll get? First term secant square x can be written as it is, but let us write this secant square x in terms of tan using second trigonometric identity. 1 plus tan square theta is equal to secant square theta. So this secant square x can be replaced by 1 plus tan square x. Followed by this secant square x into dx is nothing but dt into tan x is nothing but t whole power 4 is t power 4 will get. Okay, and this tan square x, we have tan x, if tan x is equal to t, then tan square x will become t square. Accordingly, the entire terms can be rewritten in terms of t, 1 plus t square into t power 4 into dt. Now multiply the terms, open the bracket and finally find the integral. You will get the answer as easy as possible. T power 4 into 1 is t power 4. I am opening the bracket. T power 4 into t square will become t power 6 into dt as it is. When you find the integral of these two terms with respect to t, we get t to the power 5 divided by 5 plus t to the power 6. T to the power 6. Integration of t power 6 is t power 7 divided by 7 plus c. When we substitute back the value of t, we get tan power 5x whole divided by 5 plus tan power 7x whole divided by 7 plus c we are getting. Now you can observe our answer is exactly in the form of tan power mx whole divided by m plus tan power nx whole divided by n plus c. And here m and n are respectively 5 and 7. So after finding the value of m and n, we need to find sum of m and n, that is 5 plus 7. What is 5 plus 7? It is 12. So the required value of m plus n is equal to 12. Hope you have understood. Moving to the 8th question. Let us consider 8th question. So question number 8 is integration of tan inverse of secant x plus tan x into dx. Secant x plus tan x into dx. Yes, this is the given question. Now to find the solution of this one, what you can do, let us think about rewriting the given problem because it doesn't look like any of the standard formula. So I hope you can rewrite this question as tan inverse of secant can be written as 1 by cos and tan can be written as sin by cos. Accordingly, I have rewritten the given function. Now let us take LCM within the bracket so that we get tan inverse of cos x is an LCM, then the numerator will become 1 plus sin x whole divided by cos x into dx. Okay, now we need to think how can we represent both numerator and denominator. So here numerator can be rewritten as by using trigonometric identity. See, this 1 can be written as sin square x plus cos square x. Okay na? Similarly, or else sin square x by 2 plus cos square x by 2, because this is in terms of submultiple angle formula. And sin x can be written as 2 sin x by 2 into cos x by 2. Similarly, the entire denominator can be written in the form of, and there are 4 formulas are there. For cos x. So if I write cos x, which is similar to the numerator will become a square plus b square plus 2ab, that is sin x by 2 plus cos x by 2 the whole square. So sin x by 2 plus cos x by 2 we are getting, which means combination of sin and cos. So this cos x also we will write it in the form of combination of sin and cos. So we can write it in the form of cos square x by 2 minus sin square x by 2. With the help of these formulas, we are rewriting the given question. You can observe this step will become integration of tan inverse of 1 can be written as sin square x by 2 plus cos square x by 2, and sin x can be written as 2 sin x by 2 into cos x by 2. Together it becomes sin x by 2 plus cos x by 2 the whole square. Writing the same, sin x by 2 plus cos x by 2 the whole square. Whole divided by denominator is a square minus b square format. This can be written as a plus b into a minus b. That is cos x by 2 minus sin x by 2 into cos x by 2 plus sin x by 2. You will get cos x by 2 plus sin x by 2. Okay. Now the numerator of one sin x by 2 plus cos x by 2 and denominator of 1 sin x by 2 plus cos x by 2 can be cancelled. What is remaining? Remaining is integration of tan inverse of another sin x by 2 plus cos x by 2 whole divided by cos x by 2 minus sin x by 2 you will get. Okay now, and this entire bracket when we divide it by cos x by 2 we get the terms are like this, that is integration of tan inverse of numerator can be written as cos x by 2 plus sin x by 2. Accordingly 1 plus tan x by 2 you will get. I have interchanged the position of sin x by 2 cos x by 2 and divided by cos x by 2, dividing each and individual term by cos x by 2. Accordingly I am writing yes this into dx. Now see, this one can be rewritten as, see, this is in the form of tan a plus tan b whole divided by 1 minus tan a into tan b, which I mean to say tan of pi by 4 plus x by 2 you can write. You can observe properly. You may have studied in inverse trigonometry function reducing the given problems into a simplest form. So this is also of the same format. First we will reduce the given problem into a simplest form, then we find the integral. See, tan of a plus b is tan a plus tan b whole divided by 1 minus tan a tan b, where a and b are pi by 4 plus x by 2 respectively. Later on tan and tan inverse can be cancelled. We are left with integration of pi by 4 plus x by 2 into dx. When I find the integral of these two terms we get pi by 4 is a constant, we will write as it is. Integration of dx is only x plus 1 by 2 is a constant, we will write as it is. Integration of x is x square by 2 plus c. So final answer will be pi x divided by 4 plus x square divided by 4 plus c. Yes, this is our final answer. Pi x divided by 4 plus x square divided by 4 plus c. Yes. Next, question number 9. Ninth question is integration of 2 to the power x whole divided by 2 to the power x whole divided by root of 1 minus 4 power x into dx. That is equal to k into sine inverse of 2x, k into sine inverse of 2 power x plus c, 2 power x plus c. Then the value of k is, so here we should find the value of k, and they have given the question with a partial answer. So in place of k we will get something else, so that we should find the value of k. Now let us rewrite the given question of the following form. So when we rewrite the given question, which is of this form, then the given problem can be solved as simple as possible. See here, 4 power x, 4 can be written as 2 power 2. 2 power x the whole square is nothing but 4 power x only we will get. Okay. Later on, since this is like a composite function, we are assuming a power x as a t. Okay. When I assume a power x as a t, let us see what we will get here. When I differentiate this LHS with respect to x, RHS with respect to t, we get 2 power x. Differentiation of 2 power x is 2 power x into log 2, a power x into log a format is equal to dt. So remaining part of the given question is only 2 power x into dx. So find only 2 power x into dx value. We get dt divided by log 2. dt divided by log 2. So rewrite the given question. When I rewrite the given question, we get the answer of the following form, that is integration of 2 power x into dx is nothing but 2 power x into dx is nothing but dt divided by log 2. In that dt is a function, a dt, only 1 by log 2 is a constant that I am keeping outside the integral, whole divided by root of 1 minus 2 power x the whole square. 2 power x is t, square of that one will become t square. And now this is in the form of integration of dx whole divided by root of 1 minus x square, that is sine inverse of x formula. We get 1 by log 2 into sine inverse of t, where t is 2 to the power x plus c. Finish. We found the answer. When I compare my answer with the given RHS, in place of k we have 1 divided by log 2. So the required answer is k is equal to 1 by log 2 is an answer. Hope you have understood. Moving to the last question of today's video session, that is 10th question is integration of cos x whole divided by 10th question, integration of cos x whole divided by cos x whole divided by sin x into log of sin x into dx. Okay, this is the given question. Now think about the given question. How can we find the integral of the given function? Obviously, the inner function is sin x, but if I take only sin x as a substituting variable, we will get only cos x. The remaining sin and log will never be resolved. So better you consider the entire function as a substituting variable. That is, if I assume let log of sin x is equal to substituting variable, then differentiate LHS with respect to x, RHS with respect to t. So differentiation of sin x, first I will consider inner function as a first function, outer function will be considered as a second function, so that we get simplified answer. No need to rearrange the terms. Differentiation of sin x is cos x, and differentiation of log x is 1 by x. 1 by x, in place of x we have sin x, into dx is equal to dt. Okay, so you can observe here 1 by cos x divided by cos x divided by sin x into dx value, directly we are getting as a dt, so that the given problem can be rewritten as integration of cos x by sin x into dx is nothing but dt whole divided by log of sin t, we took it as a t. Integration of dt divided by t is nothing but log of modulus of t plus c. Finish. Substitute back the value of t, so you will get the final answer. The final answer is log of modulus of t value. What is the value of t? We have taken log of sin x, so this is our final answer. Log of modulus of log of sin x plus c. Hope you have understood. Thank you for watching video.